everyone, and welcome to one of the most generic episodes of this Learning Rust class you're going to have. That's right, this episode's so generic, we're going to be writing some generics. Now, if you don't know what generics are, it's a way in computer science for us to write some code that works for more than a single type of object. Now, in Rust, you can write generics for any first-class citizen. This includes structs, which we've written. It includes enums, which we've written. It also includes functions, which we've written. And it also includes traits. Now, this is the first of at least one part in generics because there's a lot to cover. Now, we're going to really lightly cover traits. And we're going to then roll into the generics. And then we're going to come back and talk a little bit more about traits. All right, so let's talk about what a trait is at a really high level. A trait is just effectively a interface that you would have in another language. A lot of other languages have these interfaces that kind of define a contract. You can think of it as defining a contract that if X implements Y, you can expect it to have this function. And that's pretty true, but it's a lot more tied into generic code in Rust and has some other features that we'll explore more later in depth. So let's write a really simple trait. And we're going to say that my trait has a function called print that takes that's not a method, that doesn't take a reference to self, and just print something. That's all. So this is our trait. Now, if you remember right, our point, the point that we've made up to this point, let's type it out again. So it's struct point, and it was an x of I32 and a y of I32. I like repeating these things. The more you type it, the more you repeat it, the more it comes second nature. So I know we keep typing out this point, but this is how you make a struct. This is how you define its variables. You're going to do it a lot, so keep doing it, and the practice, it will become second nature to you. All right, so this is a trait that we could implement for point. So let's go ahead and do it. And we've done this in the past. We've kind of briefly talked about it. We do impl. Now remember, we can just make an implementation of point that has its own methods, but we want to implement my trait. So we'll say impl my trait for point. And in here, if we try to save this, Visual Studio Code, the language server, is going to complain and say, not all trait items implemented, missing print. Oh, we're missing the print. We're required to meet this contract. So let's go ahead and do that really quickly and easily. All you do is, fn print, and we don't have to do anything. We don't have any returns. We don't have any indent. We literally just have done it. But we could also do, a print line and say, hello from our trait. It's not really a method, but it kind of is a method because we didn't have a reference to self. This is a weird function. Really, I'm not sure why it exists, except that I was keeping it simple, very simple. We don't have a reference to self, so we can't actually talk about self. So could we do that here? Yeah, let's actually do that. We can do just self again. We're referring to ourself, and you can see our function no longer meets the right thing. It needs an @ reference to self. Now we can get to ourself. So this is really cool. We have a reference to ourselves. We know we're a point because we're in the implementation of point, and this is cool. We could just do, something like this. Not like this, like this. And we're going to, point doesn't implement display. This is the trait that we're going to talk about for the rest of this video. And we're not gonna worry about our trait because it's a pretty silly trait as it is. We have our point here, and we're gonna update this. This used to just take an I32, but what if we'd like to make points out of other things? We like to make lots of different types of points. So let's update our point to be generic. Now, I'm going to rename this old point because we're going to come back and use this, point old, and we're going to make a new point. So we have our struct point, and here we're just going to give our generic type T. This is the generic type that we're dealing with here. It's T. So when we want to use it, if you look up here, remember that we gave these a type. And in this struct, we can go ahead and do that. We could say X is an I32. That's fine and plausible. But the real power comes also in here. You can use the type T. And we'll say that Y is the same type T. Although you could define two separate ones. So you could have T and V, and this one could be of type V. If you remember, we're not going to do that for point. We're going to keep this simple. If you remember, though, our result, this result here, is a type T and E. The E stands for error, and this is the type, the value that you want to return. But it's two different types. And remember, it's an enum. Okay, cool. And with this struct, you can use it just like you would another struct. So let's actually implement a function on this. We can say, impl type T on point of type T, and we want to make a new function. Fn new x of t, y of t. And this is going to return a point of type T. Now here is one of the places where you could just use self. So instead of saying point T here, you could just say self, and we'll do that in a function here in a second. We'll do that right here. We'll do self X and Y. Now again, we could have said, instead of returning a self, we could have returned a point. This is fine, but we're just going to use self here for an example. Another thing that we're going to do here is when you make a generic, you can't call any functions on this. So these types don't have to be primitives. They could be other types. But if you wanted them to implement a trait and be able to call on them, you need to do a few extra things, and we'll learn about those very shortly. Now, another function that we'd like to do, we want to do a mutable something on this. So let's make an update function. So we're just going to make an update, and this is going to take a mutable reference to self, mutable self. It takes a type T, an X of type T, and a Y of type T. And all we're going to do is update our state. So let's do self.x equals X, self.y equals Y. We didn't have a return type. We're not returning anything. There's no failure state here. We're just mutating ourselves. So this is really cool. We've created some generic code, and now this point is generic. This is very common for collection types, your lists, your hash maps, your hash sets, all those collection types, your binary search trees, your double linked list. We can go on of all the different types of collections. This is usually the thing that powers those types of collections, and it allows you to use your own type. In fact, let's use our own type. We have this old point. Let's make a point of old points. That's a very interesting concept. We're a little inception here. So let's do that right now. We're going to say let old point equal old point. We're going to give this a x of 5 and a y of 10. All right, we've created our own point. Easy peasy. Now, let's create a new point. And this is something that's going to be a little crazy for your first time rusters, but you don't actually have to declare the type. Yeah, that's right. So we've seen the really good inference engine where, a lot of the times if you say let x equal 5, you don't have to tell Visual Studio that x is an integer. It says that it's an I32. It's only if you want to define it as, let's say, an I64 that you would have to do I64 here. Because its inference engine is going to make it what it needs to be. And in fact, if you pass this into a function that required an I64, it would define it, it would infer this as an I64. Very powerful. And that works with generics as well. So we defined an old point here, and you would think that we would need to define the type of our new point here, because it takes a generic type. But that's really not true. Let new point equal point x equals 5 and y equals 10. You can see Visual Studio Code isn't complaining about this. It's okay. In fact, the only thing it's complaining about is that it's unused. So let's use these and make sure that this is actually a point of type i32 like we would expect. So let's just use the print line macro. Print line, new point, new point. Oh, bummer. We have an error. Let's check it out. This error is saying that point doesn't implement the std format display. So the standard library's display trait. You can see it's telling you that the trait there is not implemented for it. Now, we're gonna dive more into traits in the next episode, but let's go ahead and implement this trait so that we can print it out and just see that everything is working properly. You would be familiar with how we would do that for our old point. We could do a display like this. We could implement format display like this for our old point here. I think this code would look familiar to you. I have gone over a little bit about implementing traits on your types. And this is what we would do with our old point here. We would implement display this trait. We can go check out the trait here. This trait for our point old. And it's really easy, really straightforward. We're just using self.x and self.y to print these values out. But it's a little bit more complicated with a generic type. So let's think about this and go through a couple iterations learning. Now, we could do what I would call a specialized implementation. So here is a specialized implementation. So the special implementation is we're implementing display for exactly point i32. Now the cool thing is that makes this work. You can see our code down here now is working because this is an i32. But if we implemented this for string, we're going to notice that this starts failing again because we made a specialized version. We didn't implement display for all generic point of type t's. We did it for the point of type i32. Let's try a different one. This is powerful. It is also useful because in here it allows you to know the type of type x because it is an i32. So there's a lot of powerful things you can do with this, so don't discount it. But we need to learn a little bit more. The next attempt that we're going to make this function is this. Now here we're implementing it for the type t. And so we're doing an impl of type t for point of type t. And so we're saying for implementing it for everything. That's what we're trying to do. But this is where it gets a little bit more complicated. You can see we have some problems. And the problem we have here is that t doesn't implement std format display because t could be anything. We would like to be able to put some constraints on this. We want to implement this trait display for any type that itself implements display. So what we're saying is that any type t, the type of t has to implement display. And if it does implement display, then this will work. So let's actually test that out and prove that. The way that you do that, and the really easy way here, is just to do colon and then the trait that you would like it to implement, fmt display. So here we're saying that t needs to implement display, and now this works. You'll also notice that our error has also gone away. Our new point now works with this because it itself implements display. Really cool. Now, I want to point out one odd point here is that if the type that you put in here isn't of a type that implements fmt display, then this will still fail. So let's actually do that right now. We're going to do let old point 2 equal point old x of 2 and y of 2. All right, so now we're going to have a new point. Our new point that is of type, that type T is of our point old struct. So let's do that now. Let new point 2 equals, it's going to be a point. And again, we're not going to have to tell it what type it is. X2, X is going to be of the old point, the original old point, and Y is going to be of the old point 2, old point 2. Now, you can see right off the bat, this works, and it's going to complain that it's unused. So let's go and try using it, but you'll notice that it knows what type it is. It's a point of type point old. Pretty cool. Let's implement, let's print this out. Print line, point of old, point olds, new point 2. All right, now you might be thinking, Merrick, this shouldn't work. You're forgetting something. Old point implements display. Let's delete this for old point. Now it doesn't work. Because our type T limited it to things that already implement display. The inner type, type T, has to implement display. Pretty cool, pretty nifty. Now, there's one more way of writing this here where we're constraining the type. So let's cover that one last way. Let's do it. I am going to leave these commented in the code. So if you go and check out the code, which you should, it's all out there. These will be left in commented so you can see the different iterations that we've done. Now, this last way is the way that I actually prefer doing it the majority of this time. This way is great for one type and very simple, but it gets very cumbersome very quickly. This next way is probably the best way of doing it, but it's a little bit more verbose, which is generally a pretty good thing, right? So what we're going to do is just do the impl of type T, just like we started with. And we're going to implement display for it, for our point of type T, just like we started. But instead of doing a curly brace right here, we're just gonna start a new line and say where T is a FMT display. And we'll just copy and paste the contents of this method. So yeah, that's it. It's a little bit more clear, and what really is nice about this is when you're getting into multiple variables, and we'll go more in depth on more advanced trait things in the future. But yeah, that's what I wanted to show you. Those are kind of the ways of doing it. You have your your specialization, your specialized implementation. You have your generic implementation, and then you have your a little bit more verbose method as well. Now, I said that you could do this with enums. You can. I'm not going to show you enums. We're going to do more of enums and generics in future episodes when we're starting to do some projects. But what I did want to do is show you how to make a generic function, which is pretty cool. So let's go ahead and do that now. Let's make a function to print a point. So we could make this function. We could say fn print point. And we're going to say it's a generic type of T. And we could do, P is a point of type T. Now, you're going to run into the same issue. This literally could be anything. We don't know how to print it. So a lot of the times when you get into this, you're going to want to make those requirements on a trait. So let's do that right now. We're going to say this is a FMT display, and now all we can just do print line like we have been doing, and call our point, and we can just pass in P, happy little P right there. There we go. This is our generic function, and we can call it with a point. So we can just do print point here, and pass in our old point. No, this is not for our old point. This is for our generic point. So new point 2. And this is completely happy, completely fine. And again, if you're wanting to make a little bit more complicated and want that more verbose wording, you can do it. This right here is the exact same thing here. we just put it in a where statement, which is pretty nice. And again, the way I do it most of the time. All right, but what if it cannot know what type it is? And so we're going to get into that. That's a more advanced. If it can't derive what the type is, that is going to be something we talk about in the future, because you can get into a point, you can get to a point where it can't infer what the type is supposed to be. And when that happens, you need to tell it exactly what you want. So it's pretty easy. All you do is your colon point I32. And you're saying, we're explicitly stating what type of point this is. Pretty awesome. And if we said this is a point string, for example, you'll notice this complains because these are the wrong type. Now, we can get into exactly how generics work. How does Rust implement these things? If you guys would like an advanced, like a super advanced class that goes into how generics work at the compiler level, and it changes with what language implements it. In fact, how Go implements it actually changed in versions of Go. From Go 1.18 to Go 1.20 had major changes in how they actually implemented the compiled code, which had effects on the runtime. It's pretty cool stuff. If you guys would like me to dig more into those types of things, let me know, because I would love to actually dig more into those and learn those things better myself anyhow. This is all I have for generics part 1. My next episode will be generics part 2, where we cover more about traits and how they work with generic code. And we're going to write a little bit more generic code. And then after that, we only have one more lesson on package management. And then we're off to the races of actually writing our own projects. And we're going to have a little bit deeper, a little bit more in-depth lessons after that are their own little mini-series, like a series on threading. So I think it's pretty exciting. We've learned quite a bit. And yeah.